Hello everyone and welcome back. So Lee, what's your plan in this video?
Well, our screen's already open to it, so most people probably already know where we're going. We're going to be looking at one of the more popular libraries for generating noise out there, particularly LibNoise. Now, LibNoise is kind of neat. There's all kinds of builds for it all over the place. The one that we're looking at, because we're using C# and .NET, is the LibNoise for .NET.
Okay.
So we're not going to delve into it. There is a lot of stuff that this library does, stuff that we're not even going to look at doing in our library. This has the ability to project noise on spheres, do planets, all kinds of really, really cool stuff if you want to delve into it. And if you're really, really into noise, I recommend it. It's a good place to look at how to do stuff beyond the scope of what we're doing with noise. But it does have some downsides, which is why we created our own library, mostly for the educational purposes of being able to figure out what noise is, how to implement it, because LibNoise, being a library that runs inside of C#, doesn't run in shaders. And one of the things that we're going to need or at least I'm planning on using heavily, is noise inside of shaders for controlling just the look of our shaders to help give it a more organic feel, the possibility of animating things inside of shaders, which would require a noise. And unless I wanted to generate all my noise on the CPU side, save it out as a texture and pass it into a shader, it wasn't practical to, or it didn't, I didn't want to have to rely on having to use the CPU to generate all my noise. I want to do it shader side. But you
Graphic
can't,
card side,
yeah,
GPU side.
GPU side, graphic side.
And just a second ago you said that we did this for educational value. Wait a minute. You're going to be using these noises that you've created in the MMO, right?
Oh, yeah.
Well, that's more than just for educational purposes then.
Well, that's true. But, if you don't understand how noise works, you can't write it in shader. If you can't write it on CPU side, I guarantee you can't write noise
Yeah.
on shader side. So we start off simple by learning what noise is, how it works, write it on the CPU side. And if we get something that we can use that is, maybe looks better, or not so much better, but looks more the way we want it to. But because LibNoise can make some really awesome noise, or looking noise, if you spend the time to tweak it. But that can get us what we want to look at and can run as fast or faster, why not use it? Because, like I said, LibNoise has a lot of features in it. So it's got more things than we need. So what we're building is a highly optimized, stripped down version of noise generation to do what we need. So, but here's
Yeah, you've gone.
yeah,
Yeah, I was just
let's
going to
get
say.
into it.
Yeah, you've gone to downloads. You've already downloaded
Yep,
it,
I've
and
downloaded it. So we
whoops,
downloaded the RAR.
and
You've already uncompressed it for me and threw it in a folder.
and this is the only thing that you're interested in. I'll hand the mouse
Yep,
back over.
yep. The DLL is what we need. So we're going to drag it right into our project. We can go ahead and close this now. Now, click on this and wait for the bar to go away. I want to create a new folder. I like my projects to be organized. And while this is not a very big project, our R&Ds and our MMOs at some point in time are going to be extremely convoluted with files and folders and assets all over the place. So if you don't keep organized from the start, you're going to end up with a mess that's going to be almost impossible to deal with by the end. So I'm just going to create a plugins folder, and I'm going to put my LibNoise DLL inside of it. To make use of it, we have to go and add it to our references. So if I jump back into Visual Studio, right-click on References, add a reference, go to, wow, this one
Browse,
looks different. Yeah.
browse, bottom right.
Why does yours look different than mine?
Because mine's uber cool.
Yeah, you let Nelson add it again.
No, this is actually me.
Oh, this was you?
Mm-hmm.
All right, so
There you go.
now I've got LibNoise. we can go to our game manager. Let's go ahead and add another private. This will be a LibNoise noise, and I'll call this LibNoise. So, can't find that. You're not going to give me the option to... Interesting. ReSharper failed.
Or it's just gone to bed for the night.
Yeah. And LibNoise, what type of noise shall we use? Now, it comes with a bunch of different presets, but it doesn't have a simplex noise in there. It does have a Perlin noise, though. So let's use LibNoise Perlin to start with. So scroll down here. Go noise. No, not noise. LibNoise. LibNoise equals new. And why do I have bad feeling about that?
Why? No, no, no. Okay,
What?
hang on. I promised I'd stay quiet, but why are you even using this? Hang on. No, give me a
What? What
second.
are you doing?
You've
What?
already got a using in there.
Oh, yeah.
So why? So yes, you were on the right track a second ago. There you go. I know I said I'd be quiet with coding stuff, but
You lie. You always
I
do.
no, I've been quiet overall and throughout all your videos. You crazy? Okay, good.
Uh, yeah. I didn't use the using on mine. So, but I'm just trying to keep it consistent with my notes. All right, I want to set some of the values so we can get something relative. So let's go with octave count. Now, some of these are the defaults. If you go through the source code, octave count defaults to 6, I believe. So LibNoise, let's set our frequency to equal 0.1. And lacrinarity 0.5. And persistence equals to 0.5.
Is that all? Is that what you want to set there?
For now.
Okay, good. So let's go ahead and use an object initializer. All right, continue.
What?
Nothing. Continue.
No. Why'd you do that? Now you confused me. You threw me completely off track.
Get with modern times, my friend. Just kidding. Keep going.
I have absolutely no idea what that is.
That's just an object initializer. It's been available for a while.
Really? Nice.
Yeah.
I never use them.
I know you're old school.
Yeah, very much so. You could have told me before I typed all that out, but, whatever. Now I'm completely sidetracked again.
No, you're not. Come on. All right. So next thing you wanted to do.
Yeah, I'm working on it. I'm trying to remember what it was.
So you just instantiated your new Perlin.
Except you went in and you made that public. That was supposed to be private.
I didn't make that public. You made
no,
that public.
That is supposed to be public.
So you could adjust it in the inspector.
Yeah, it's late. Wow. I mean, really derailed my brain there for a sec. Let's see if I can recover this. All right. I need to have a Boolean that will track whether or not we're going to use LibNoise or not.
Okay.
And I'm going to initialize this to true. So we're going to start off with LibNoise. Inside of update, let's see, if input dot, let's do get key down, and key code dot, let's use F1. So we'll use F1 to toggle whether or not we're going to use LibNoise or not. So use LibNoise equals not use LibNoise. Now if I go back down, inside of here, if we're not going to use LibNoise, we're going to use our version here. But that also means that we're going to have to initialize or set up our color data outside. So we'll go color array called data. Get rid of the var for our data. So if we're not using LibNoise, go ahead and do it that way. If we are using LibNoise, we're going to have to initialize our color array. And that will be our texture size times our texture size. That's going to drive me nuts. I have to change it. It's like, oh, no, I'll just leave it. No, it's going to drive me nuts. All right. Now, we need our nested loops again. So for y equals y0 to texture size. Wow, that was great. I was pretty sure I hit line down, but whatever. All right. Now inside of here, we'll specify a var n. That's going to equal what we get back casted to float. And what we're going to be looking for is our libnoise dot get value. They don't have get values, so we have to hand request information. So iteration, but they also return -1 to 1, so we have to do the add 1 divide by 2. Really? You had to do that? Alright, so I'm going to take our y, multiply it by our texture size, add x to it, and we're going to create a new color that will be based off of what we get returned from noise for our red, green, and blue components, and we'll set alpha to 1. Wow. No OCD there. Alright, so if I build that out, how do I want to do this? Before I even do that, I want to change our simplex to be Perlin, because we're asking for their Perlin. Let's compare it to our Perlin. Alright, so if we run, alright, so we're getting our noise generated based off of LibNoise with a render time of about 110 to 116 milliseconds. We hit F1, switches up to our Perlin at about 38, 39 milliseconds. A little bit smoother, but like I said, this is just directly out of the system. I've taken no time to process.
I can't remember. Are we doing the same amount of octaves as you set up for LibNoise? I know you set up 6 for LibNoise.
Actually, I think our default is set at 5.
So let's make sure we're doing the same amount of octaves.
Yeah. That will be if I get on the right screen as opposed to my computer. Ignore. So let's go to our noise, which is here. So if we go to noise, default values, there, so 6. And then I go back to here, run. So still the same there. And I need to adjust our gain. So we're getting blown out, which is why we have sliders. All right, so let's put some stuff in so we can adjust that.
Okay.
We're going to have to do it anyways.
Mm-hmm.
All right. What we're going to do is set some more public values. Set in integer. We'll call this octaves. Public float. This will be frequency. Public float. Lacunarity. Public float. Persistence. And public float. Yep. Gain. All right. Now, I need to set all those. You got any really cool tricks for that? Or can you only do that on initialization?
Huh?
Well, before
I wasn't tuned in. Sorry.
before I start going noise, octaves equals octaves. Just wondering if you had any really handy shortcuts.
I'm sure I do. I'm just not thinking at the moment. Sorry.
That caught you off guard.
Yes, you did.
Paybacks.
You know, Angie was having a problem with something and was explaining to me over in Skype what it was. Hi, how's it going? I'm back. Never went anywhere.
Yeah.
I mean, I knew what you were setting up, and it was...
And so goes most of our pair programming adventures.
Yeah, for sure.
You know, it's not like this isn't common. All right.
Cool. Now at least we can adjust it real time.
Yeah. All right. So if I switch over, wow, look, it only took 9 seconds. That's
9
awesome.
seconds.
Yeah, there might be some issues with that, though. All right. So, like everything being set to 0. So, let's adjust that to 6. 0.2.
Go ahead and change the type over to Perlin as well.
Yeah.
Phew, boy, it's taking forever.
Yeah, that's because of lacunarity.
Yeah.
If you set lacunarity to 0, we get really, really bad results. So, don't recommend doing that. And persistence should be, let's go with 1.8. Gain, we're kind of blown out before, so we're still blown out. 0.5. Oh no, I know the numbers that I was typing in, I think. Is that 0.33? So 0.15. 0.2. 5.
You're making it
2.
wider. There you go. 0.18.
0.18. All right, so about 0.18. All right, so about 86 to 91 milliseconds to 111 to about 115, back from 110 to 115, back and forth. What I was trying to do is get something similar that looks like this, but with Perlin being washed out, we don't really see that. So,
well, change your gain down to about try 1.4 or 0.14 in your gain. Okay, and now we need to we don't need such tighten it up. Tighten it up.
Tighten it up.
That's right. You got giant, big, fluffy clouds everywhere. They're getting better. Even better. Try 1.3. See, now switch back and forth. You'll see what I mean. I'm trying to get you a little bit closer into the ballpark with the look. So it's a little closer.
Right.
Take your iteration step, speed it up. It's about 0.9 maybe. Getting a little closer. This one just looks so much better, though. I mean, it has.
Well, see, the other thing is we've got so many octaves going.
Yeah. Woo!
So,
TV static, my favorite.
Yeah, that's not cool. Let's try 3. Nope.
4?
Well, no, I'm looking at the frequency and stuff.
Oh. Yeah, a little closer. I mean,
but what I'm trying to get to is the fact that I can get something closer with less octaves that looks close to or fairly close to what we get here. But I don't need as many octaves to get to that result.
Switch your noise type over to
Simplex?
Yeah, go ahead and go to Simplex. Because you can get the contrast.
Gets us really close.
Now you can slow the speed down. Maybe back down to 0.5. Now switch back and forth between that. Let me see what we got.
Because the numbers that I had for Simplex is 0.2, 1.9, 1.8, and 0.33. But I think I was using an octave count of 4. So I was going back between that one. That's not quite right. Let's do, where do I get it? 2. No, I still need, I need 3 octaves. And I can go up a bit more on gain. Let's try 0.4.
0.45. There you go.
So not quite exact, but we're not going to get it perfect. But what I'm trying to do is get the black, the white size kernel close. But we're getting a much smoother result with less octaves of noise. 30 milliseconds, 29, 30 milliseconds to 110, 115. Now, again, that's not exactly fair because we're comparing Perlin to Simplex. Now, they don't have a, let me adjust this back. So let's go with, again, 6, frequency 0.2. linearity of 1.9, persistence 1.8, and 0.18 is what we're using with 6 octaves of noise. So let's type that in for now. And if we go back into code real quick, they do have faster types of noise. Perlin is just one of the ones that they use. So if we go into LibNoise, and instead of Perlin, we used fast noise, which everything that I've run through all the different noises when I was playing, fast noise seems to be the fastest noise they've got. Which, when you take a look at it, looks an awful like value noise, the way it acts. And so if I go back into Unity now, and I run again, this is their fast noise running at about 36 to 40 milliseconds, roughly. Now if I switch back into ours,
yeah, but you need to switch over to value noise because that fast noise looked very similar to value noise.
Yeah, because it's doing the cross-fading type look. And again, for our value noise, it's just at 6 octaves is just too much.
Try 0.55.
So go back and forth. So that's, yeah, their fast noise is the best I can figure, like our value noise. But it's a lot faster at 36 milliseconds. Our fast noise at 3 octaves, we can get something similar, not exactly the same. If I were to take our frequency and dial that up some.
Yeah, there you go. Well,
Too far.
Yeah, way too far.
You want to deal with the frequency? I'm getting too much lag.
Yeah, I mean,
probably about 0.4, I'm guessing.
yeah. Yeah, something along those lines.
Right. So, let's see. They're fast, coming in at 36 to 40, and we're coming in at about 28 to 33 for our fast noise for something that looks similar. And if we go to simplex, then we have to dial our frequency
Back down.
further down.
Yeah.
So 0.2. But we get something similar in the 29 to 34 millisecond time frame. So with all the optimization that we've got, it's like we're getting something that is running faster than what we get with the default LibNoise. That's not to say that, I could be screwing up the way LibNoise is supposed to be implemented, and there could probably be some tweaks to it. I'm not a, LibNoise expert by any means. I have looked at some of the source code and found that there were some interesting things because all the noises pretty much use the same generation at the bottom. It's just the interpolation that they use to get to it. They have 3 different types of interpolation that they build in that is different quality settings for their interpolation. And there's a lot of things that they probably can run smoothing on top of it as well.
Mm-hmm.
But we found through experimentation, even with our value noise, the moment you start doing too much smoothing, your performance just goes out the window.
Right.
So, but the biggest thing is the fact that our implementation is running better than the really fast out of the can LibNoise as far as the way we've done it.
Mm-hmm.
But the big thing is now that we've built our own noise methods and know how they're derived, we'll be able to implement those inside of a shader, which is something that we can't do with LibNoise,
Mm-hmm.
because LibNoise requires the CPU to generate itself. So now we know enough information that we could take value noise and simplex noise and even Perlin if we wanted to, and we'll look at pushing those to the GPU or the graphics card in the future.
Awesome. Now, in the next video, we're going to start having... Next video is a bonus on top of a bonus, right?
Right. The next one is to have some fun.
Yeah.
Because what I wanted to do is we had the one thread that the question came up, why not just use LibNoise? Why are we recreating the wheel? And hopefully this video has answered that. We recreated it because we wanted everybody to understand what noise was and how we could create it, because we're going to need it on the graphics card. So if we don't understand it, we can't implement it. But in the as a side bonus, we're able to implement something that is faster than the out-of-the-box LibNoise for the or libnoise.net. Again, there are many implementations of LibNoise, so some may be faster than others. And I also need to qualify this. There is an exe that comes with the LibNoise library, and when you play with that application, it runs very fast in a standalone application. But because we're looking at noise as it stands inside of Unity, when run inside of Unity, so I've not done any benchmarks as far as what our noise library runs at outside of the Unity environment. I've not compared it.
Yeah, it's irrelevant because
Right.
this is the environment in which we're developing it.
Right. So that's why we've done this R&D on noise. So, but that wraps up the comparison between LibNoise, why we've gone this route. The next one is we've done all the hard work. It's time to have some fun with it.
Mm-hmm.
And it also allows us to take this little demo and make it a tool, because now that you've got your noise library, just guessing numbers is time consuming. We've offloaded the problem of generating the noise, or having to go to the code, switching out different values, saving it out, coming back into Unity, letting it recompile the code, then running Unity. By exposing those fields as public, we can now go to the inspector here and adjust those values real time. But we're still limited to being inside of the Unity editor. What we're going to do in the next video, if it maybe a couple of videos if it runs over, is we're going to make a GUI window that will allow us to adjust the settings of our noise inside of the window itself. So you'll be able to build this out as a standalone application, and if for some reason you just want to tweak around with the noise values to see what kind of values you need to get noise to look a certain way, you'll be able to do it. And you'll be able to do what I do, dial in some settings that you like, throw it on another monitor and just let it run because it looks cool.
All right. Fantastic. Well, then, with that, Lee, that's going to conclude this video. Blah. And we'll see everybody back in the next video, which, again, is a bonus on top of a bonus. Thanks a lot, everyone.